Hello everyone, welcome to my channel, Learn with Kunjan. So we have been talking about modernization. If you are wondering why, there is a video already out there about why modernization, be it for infrastructure, application, or data. So today we are going to be focusing on application modernization, and you will see that pieces of the information kind of coincide when we talk about infrastructure modernization, because in infrastructure, we talked primarily about moving to cloud. And when we talk about moving to cloud, it's not in isolation. It's with the applications, it's with the data. So you will see there is, when you look at these videos together, you will see the patterns which emerge and how they are interrelated, how you cannot move the infrastructure without moving the applications, and the interrelationships and dependencies among this. So make sure to watch those videos, and it will bring all the pieces together. Okay. So application modernization. Again, a quick recap of, because we want to do things faster, we want to do these things for a lot more customers and at which lesser number of resources, and saving the cost, at the same time providing a very good performance as well as scalability to the end user. Those being the drivers, and same are the drivers as we are moving from the legacy systems to more efficient modern systems to have better customer experience along the way. So given that, what is the pathway when applications move from the legacy stack to the modern stack? We touched upon in infrastructure modernization, we talked about how we are changing the storage, the compute, and the networking aspect, how migration to cloud helps with that. So you see but as we are moving to cloud, what considerations to have for the application movement? In the application perspective, you have to design the applications. How? Design the applications more to be cloud native. When I'm saying the cloud native application, it's not one monolith. Instead, you break that monolith down into smaller subsection. And I will show you an example of that. Basically, that's the change from the monolith to microservices. And I'll show you with that example. And we talked about in the infrastructure modernization video about private, public, and hybrid cloud, and and there I gave an example also with the analogy how to think about migration to cloud, any cloud, be it Azure, be it GCP or AWS. So those aspects you will see are more in the infrastructure modernization video. Here, we will stay focused, especially the microservices, monolith to microservices aspect. And once you have your application as more modular, like more modular microservices, you can host each of these separate microservice on a container on container, okay? And now you will see, because if we are dividing our bigger monolith applications into smaller microservices, these need to talk to each other. These microservices need to talk to each other. And if similarly, if we are using Kubernetes, basically, if we are using the containers, then we need the containers to have the information communicated to each other as well. So that's the orchestration part, which is like how the communication between the APIs will happen. So that aspect is defined by orchestration and automation aspects. So taking a deeper dive into how to think about monolith to microservice. So if you see the diagram on the left-hand side, it's like everything is together. Your front end, your database, your backend, it's all together. Think of it as like one big house. That's the monolith. But now, if we are saying you want to separate it to microservices, that essentially is each section has its own utility. Each section, for example, here you say customer support, that's one aspect. User interface, second aspect. And each aspect is its own microservice. And everything, whenever we are creating microservice, we think in terms of framework, so that what are the reusable components, and you can reuse across different microservices. What is the key reason to get there is, again, we have, so think about if any damage or if there are any issues that happen in a particular microservice, it is contained just in that microservice. It will not have impact on your other microservices. So think about if you are if you have an order management application, right? And somehow you cannot ship the orders right now, and you have your shipping application is down, but you still want to be able to receive the orders, right? And put them in a queue. So you want to still have your input order coming in, and you can, as the shipment part becomes accurate and is working, then you can ship the orders later on. So that's the modularity and decentralization aspect I'm talking about, where one service should not impact the other service. Here in our example, shipment should not be impacted by your order receiving aspect. Okay. And similarly, now suppose one microservice may need to process the things very fast. For example, if it's you are receiving the orders very fast, so receiving application needs to scale up pretty quick. But if you are doing shipment in bulk, so your shipment application may actually be can have much smaller ASGs in term auto scaling group in AWS terms, or EC2s, essentially much lesser compute. So you can scale each microservice independently. And that's how, when you move to cloud, you can save the cost, because you can segregate. You don't have to have a huge compute given to your complete application. You can chunk your application into smaller microservice, and the microservice where you have the biggest compute needs, you just scale up that particular microservice. So essentially, what this provides you is the modularity as well as scalability, that you can do each microservice scaling up and down independently, hence saving the cost. And same thing, we talked about resilience. If one microservice is going down, it will not have the impact on the other ones. So this is an example, like how you see it's in one single server, front end, back end. And like this is an example, if you have login service, like user is coming into your application, so user management aspect, all, as well as the invoices that are created by the user, all these aspects are merged together. That's essentially like merged together, right? It's one big monolith, and it's sharing the data store. That's another aspect that we see here. Whereas when we break this monolith into microservices, now each component, for example, logon and data access, that has its data store. Whereas if you are talking about invoicing, the last one you see, that has its own data store. And another aspect is you are seeing each one of them is separate on a single server in a different data store. That's essentially is the domain-driven design. You divide your application into different domains, and each domain you turn into a microservice, and each microservice to handle its data store as well as its server independently. And that's how, if the impact happens on one microservice, it will not be percolated over to the other ones, hence reducing the blast radius, even in the case if any sort of damage happens to or any sort of issue emerges in your application. So minimizing the impact, minimizing the blast radius for your users. So those are the key drivers. And again, if you want to understand it end to end, do watch the infrastructure modernization video to put these things together, as well as the data modernization. All right. So thank you for watching. If you like it, like, subscribe, and learn with Kunjan.